can misfold, something that has been associated with illnesses like diabetes, as well as Alzheimer's and Parkinson's diseases. The technology might someday be employed in a range of applications outside medicine. For example, to help engineer microbes that can secrete proteins capable of degrading waste, such as plastic or oil. In other words, it is an innovation with the potential to accelerate progress in virtually every sphere of biochemical science and medicine. Over roughly the past decade, the field of artificial intelligence has taken a revolutionary leap forward and is beginning to deliver an ever-increasing number of practical applications that are already transforming the world around us. The primary accelerant of this progress has been deep learning, a machine learning technique based on the use of multi-layered artificial neural networks of the kind employed by DeepMind. The basic principles of deep neural networks have been understood for decades, but recent dramatic advances have been enabled by the confluence of two relentless trends in information technology. First, the arrival of vastly more powerful computers has, for the first time, allowed neural networks to transition into truly capable tools. And second, the enormous troves of data now being generated and collected across the information economy provide a resource crucial to training these networks to perform useful tasks. Indeed, the availability of data at a scale that would once have been unimaginable is arguably the single most important factor underlying the startling progress we have seen. Deep neural networks hoover up and leverage data much in the way that a massive blue whale feeds on tiny krill, scooping up vast numbers of individually insignificant organisms, and then using their collective energy to animate a creature of magnificent size and power. As artificial intelligence is successfully applied to more and more areas, it is becoming clear that it is evolving into a uniquely consequential technology. In some specific areas of medicine, for example, diagnostic AI applications are already beginning to match or even exceed the performance of the best doctors. The true power of such an innovation does not lie just in its ability to potentially outperform a single world-class physician, but rather in the ease with which the intelligence encapsulated in the technology can be scaled. Someday soon, elite diagnostic expertise will be affordably broadcast across the globe, making it available even in regions where people barely have access to any doctor or nurse, let alone to the world's best medical specialists. Now, imagine taking a single extremely specific innovation, an AI-based diagnostic tool, or perhaps DeepMind's breakthrough in protein folding, and multiplying it by a virtually limitless number of possibilities in other areas from medicine to science, industry, transportation, energy, government, and every other sphere of human activity. What you end up with is a new and uniquely powerful utility. In essence, an electricity of intelligence. A flexible resource that can perhaps someday, with almost a flick of a switch, apply cognitive capability to virtually any problem we face. Ultimately, this new utility will deliver the ability not just to analyze and make decisions, but to solve complex problems and even exhibit creativity. The purpose of this book will be to explore the future implications of artificial intelligence by viewing it not as a specific innovation, but rather as a uniquely scalable and potentially disruptive technology, a powerful new utility poised to deliver a transformation that will someday rival the impact of electricity. The arguments and explanations I will put forth here draw heavily on three of my own professional experiences. First, since the publication of my book, Rise of the Robots, Technology and the Threat of a Jobless Future, in 2015, I have been invited to speak about the impact of artificial intelligence and robotics at dozens of technology conferences, regional summits, and corporate and academic events. I've traveled to more than 30 countries and have had an opportunity to visit research labs, to see demonstrations of leading-edge technology, and to discuss and debate the implications of the unfolding AI revolution with technical experts, economists, business executives, investors, and politicians, as well as average people who are seeing and beginning to worry about the changes happening around them. Second, in 2017, I began working with a team at the French bank